So sad it is. No problem. When I repeat application layer, so otherwise I will tell 2 points about application layer. Guys, I told about OSI layers and protocols and port numbers. Okay. So first one is application layer. Okay. So one by one we will go through. So first we completed application layer. Then we'll go to the presentation layer, session layer, transport, network, data link, and physical layer. So, and also I told about protocols and their port numbers, which is also involved in your application layer. So what is an application layer? Again, once again, it is server side and client side applications and dealing with the protocols and their port numbers. Okay. Client side applications are used to connect a server with the different protocols, right? So web browser for accessing websites. Outlook is a mail client application for sending and receiving mails. Putty application, example, Putty application for connecting remote SSH and Telnet servers using SSH and Telnet protocols. Filezilla, cuteFTP kind of applications are used to connect your FTP server using FTP protocol. WinSCP is one of the application to connect a remote system, remote servers using FTP, VSFTP, SFTP, okay, SCP protocols. RDP, remote desktop protocol, used to connect a remote system to access their desktop environment. So mstsc is an application, RDP is a protocol. In server side, we have a web servers to provide a web services, and they use an application to give a web service called Microsoft Internet Information Service or HTTPD, Apache HTTPD service or Tomcat applications will give you a web services. Okay, I told you something. Okay, mail servers provide a mail services. Okay, by running an application called Microsoft Exchange application, or maybe it's a Zimbra application, or maybe Squirrel Mail application. SSH servers, Telnet servers having SSH installed in it and configured as a SSH server. Telnet server means there is a server with the Telnet protocol installed and configured as a Telnet server. Same as go to the file servers or FTP servers installed with the FTP protocol or VSFTP or SFTP protocol and make it as a FTP server. Okay, so this is application layer. So whatever the guys, whatever the way of your connectivity, it can be a web related or it can be a file transmission related, or maybe it is a remote access related, or maybe it is a mail communication related. Whatever it is a data, right? While you are sending or receiving, it is a data only, either from client to server or server to client. So data is data. So that data is encoded while it is transmitting. Data is encoded. When you are receiving, it is decoded. Data is encoded into ASCII format. First, whatever the data format you are sending or receiving, HTML files or maybe text files, JPG files, MP3 files, lot of different format, PDF files. Okay, any format of files, it is converted into ASCII format. But ASCII, what is ASCII? American Standard Code for Information Interchange. And that will be converted into binary format. Okay, that will be converted into binary format. And data is compressed and decompressed. So whatever the data, huge amount of data is there, it will be compressed and decompressed. Data is encrypted and de-encrypted. For example, you are using HTTPS, data is encrypted, right? So in a presentation layer, three main duties, guys: encoding, decoding, encryption, de-encryption, compression, decompression. Okay, understand?
Yes, sir.
Yes.
Okay. Next one is session layer. Session layer, I written only one single line, that too 3 words only. Okay, but personally there is a lot of things about a session layer. So orally I'm telling, just try to understand, guys. Session layer, basically it will create a session and maintain the session and terminate the session. Means you are sending, it means your data is located in different places, and who is requesting? I want to get my mails. So I have to ask with my mail ID password, right? So session layer of server, it will authenticate. So who is that user? Why should I give it to him? And what is his request? And where is the data? Assemble the data and start providing. Okay. So simple. I try to open this website without any login credentials. How server understand? How I'm sending my credential? Anonymous. Is this can be open for any anonymous users, or for a particular type of users, or particular username passwords only? Okay, particular age group only? Okay, so particular geographical range only? So like that. So there is a first authentication. Second one is, this data is not in one place. For example, I open some pictorial oriented kind of stuff. Canvas is better. Yes, it is. There is a script kind of stuff, pictures, links, okay, links, pictures. So much of data is here. This is good one, actually. It is contains a lot of pictures inside. Yes, it is. A small elephant picture is there. Video links are there. Okay, here also some pictures are there. What is the point of this one? Okay, how means data is in what data I want to send, so that will be assembled based on the user request at a session layer. Authenticate and assemble the data into one place, protocols, the required port numbers, and create a session ID for that one. Create a session ID, deliver information to the client purpose. This session layer is important. Out of all layers, the session layer having only single line or have only one, maximum one paragraph information, but session layer is having vital role in your network communication. I will tell you to understand. Very simplest thing is your session layer in do you remember Amazon or Flipkart or maybe an IRCTC? You buy things right through online. So what you will do? You will enter the information. You enter the your home address. You add the things to the cart. Then finally go to the payment. Finally, you are going to the payment. In a payment, so you given a details and click OK. Then it will on the screen. It shows do not refresh or press the back button. You know why? Because It's like this. For example, this is Amazon, this is the bank, and this is your client from either it is a mobile phone or it can be a laptop or a desktop. You send a request, you are giving information to Amazon, your bank details and your product information you are given and added for payment you are done, you given a bank details. So that details will be verified with the bank. So bank verifies your details and cut your money and give that information to Amazon. So yeah, amount is deducted and this is the transaction ID. That amount will be transferred to Amazon. Okay, the amount will be transferred to Amazon. Amazon confirms your product. Okay, they received a payment from your bank. Then they confirm your payment. Now you are getting yes, order is placed successfully. Then tracking. Understand guys what is happened at Amazon? You add a product, then you go for a payment, you give the payment details and click OK. Data go to, information go to bank, verify your amount and amount will be detected and give it to Amazon. Amazon received your payment and confirms your order. Now it will shows what is your order details confirmation. But meanwhile, on your screen it shows do not refresh or do not press the back button. Why? If you do it, what is the possible things will happen? Tell me. Tell me. I'm disconnected or connected.
So you are connected, sir. Might be when you'll refresh the details which are required to be sent to the server, the original server will not be get sent. Might be.
Okay, good. Okay, good. So it is this entire thing will happen in one session only. In one session only, this entire transaction must be completed. Any network changes, network disconnected, refreshes happen, the session will be changes. The session ID will be changes. So what happened? Money can be detected, but meantime you are refreshed now. So this money went to somewhere. It went to the Amazon, but not to your product related. It went somewhere. If it is early detected, so automatically you will get a money back from Amazon to bank. Okay, so bank. Okay, if it is not detected, so then you will get a problem. Sometimes, luckily, the order will be placed, money will be detected, and order is placed. Luckily, your product is there. Sometimes money will be detected, it not showing any order is placed or not. Sometimes order is placed, but it is not showing. Okay, so it is sometimes it is very dangerous to refresh when payment is going on. Like that, guys. This is for our understanding. A lot of cases. So your network is disconnected, or maybe even for me also it is happened. So that's why I'm telling this kind of stuff. Okay. Sometimes it will take time now. So it is keep rotating. Do not refresh or press the back button. You are waiting for a very long time. The session is automatically complete after a certain period of time. Okay, any network disconnections, any backpress, refresh, change of network, it disturb your session. So session ID will be cancelled and it is new session ID will be created. So obviously it is difficult. Simple thing guys, understand. there is a queue line. This is a queue line, queue line. You are weighted. Your position is here. And this is like this. What you done? You jump to the 9, but still you are new to the thing, right? Again, entire process has to be done. Okay. Similarly, if you change a network in between, also session ID will be corrupted, or maybe it is over. Yeah, another session ID will be created. You refresh, new session ID. Okay. So this is about session layer, guys. Session layer, it creates a session when your transmitter receives, that works based on a session on. Okay. So to deliver what are the requirements, it will assemble it. It attached with the session ID, and the entire transaction should be completed within the session. I open this page. When I send a request, with that session only, I got this data. After some time, maybe certain change occurs in the server, that will be updated. Best example I will tell, Gmail. Okay, so I am sending request to my Gmail server and I send my username password. Now I got a information on my system. So meanwhile, I received a new mail. New mail also will be updated. Transaction completed, but how I'm getting a new mail? Because the browser do that refresh means repetition of session again. It refresh means again request will go and will get update with the same network or different network. The browser is keep doing this refreshment. Okay, that's why when your new mail is there, so you will get immediately. Okay. Okay, I checked a mail. Now I received a new mail. I will get it like based on a session will be re-established. So there's a lot of story, guys. So we'll go to the next one. So basically, so that is a session layer. Session creates, maintain, and terminate your session by session layer. Okay, transport layer. What is a transport layer? Provide end-to-end connectivity. It is a heart of OSI layer. Okay. What is a transport layer do? Transport layer chop the data into small pieces. It cut your data into small pieces. For example, you have a thing like a hello, how are you? We are sending this message, for example, just for our understanding only, guys. So whatsoever it is a data, it will chop the data into small pieces called as segmenting. So maximum size is 1600 bytes. Sorry, 1500 bytes maximum size. Minimum size is 64 bytes. Any data is less than 64 bytes, it is chunk and it is invalid data. Okay, forget about it. So what is segmenting? Chop the data into small pieces. And there is a sequencing and numbering. So what it is? It puts certain number on this data. It put the number on this data. This is called a numbering and sequencing. What is the advantage of this numbering and sequencing? Look at here, guys. There is a APC and BBC. So it's a source and it is a destination. I send a packet. For example, I send a first packet. So destination received it. Destination will send me an acknowledgement, that is, I received a packet. It means hello is received. I send another packet. It is received. So then I got a acknowledgement. Means A understand A understand how also received. Second is also received. I send third packet. Third packet is not received. It does not send any acknowledgement. No acknowledgement. And I send fourth packet. Fourth is received and I received an acknowledgement. It means U is received. So 1, 2, 4 is received. Now things is source. Understand this third is not received by destination. It send the third packet again. So once it is now third packet is not received, so it will send the third packet. Now it is received. Now acknowledgement 3. So now everything is received. The third packet is R. Okay. But it is not in a proper order, right? Because of this numbering, this we can able to reassemble. Again, it will reassemble again in a proper order. Like this. Okay, so that is the advantage of numbering and sequencing. So at destination, it will put the information into proper order using numbering and sequencing order. Okay. And I said, if one of the packet is not able to receive, we can send it again. Okay. How it is? Because we chop the data into small pieces, we are sending packet by packet. Another one is, this is also called as a error correction. Error detection, error correction. Okay. Error correction. So if any data is missing, so no problem, so we can able to send it again. See, this is a hello, how are you data is there. So I chopped this data into small pieces. At destination, I received some packet is missing, so sorry. It is called a error correction, guys. It means source knows destination is not received a packet. Source knows destination not received a packet, so we'll send the packet again. We can send the packet again. At destination, because of numbering and sequencing order, so it will do reorder the data again. Okay, understand?
Yes, sir.
Very good. Multiplexing and demultiplexing of protocols. Guys, we have seen the protocols and port numbers, right? We have seen different protocols: HTTP, FTP, SSH, SMTP, TFTP, DHCP, DNS. These protocols are two types. Two types means two different type things. It is, there are TCP type protocols and UDP type protocols. It is. Some protocols are TCP type protocol, some protocols are UDP protocols. Just trying to get protocols and their port numbers list. So either from Wikipedia or any other things. Yeah, this is Wikipedia. Okay. So this is port numbers, and these are the different protocols. Really confusing because we learn in reverse order SSH 22. FTP 2021. Okay, TCP UDP. So yes, it's both are TCP UDP. This is yes assigned. No, not like that. We don't want like that. Yeah, it is at least good. So it is, there is a protocol. Certain protocols are TCP type, some are UDP type protocols. Okay, so it is Telnet TCP, SMTP TCP, DNS TCP and UDP, TFTP is UDP. Okay, certain protocols are TCP type protocol, certain protocols are UDP protocol, some are both. Some protocols are both properties having that. So protocols are either TCP type protocol or UDP protocol or maybe both. TCP means transmission control protocol, UDP user datagram protocol. TCP is an acknowledgement based protocol, UDP no acknowledgement, we don't have any acknowledgements here. What is acknowledgement based protocol? Original TCP UDP is synchronization, so much of things are there. So we don't go to that part. We'll telling only simple thing. Okay. So what is TCP? What is UDP? Guys, this is the source and this is the destination. For example, this is PCA. This is PCB. PCA send a packet, so PCB received a packet. So if it is a TCP type protocol, I am using a TCP type, means either it is HTTP or Telnet or SSH or FTP type of protocol or SMTP type of protocol. It is in that type of protocols, the communication is like that. You send a packet, destination received, destination will give you an acknowledgement. The destination will give you an acknowledgement. It means source understand destination is received a packet. Source knows destination received a packet or not. Source send a packet. Destination received a packet. Source send a packet. Destination received a packet, and destination will send an acknowledgement. So source understand, yes, this packet is also received by destination. Source send a packet. Destination received or not received, we don't know, because I didn't receive an acknowledgement for a packet 3. Source not received a acknowledgement for a packet 3. So what is that meaning? It thinks destination is not received a packet 3. Okay, so source send a packet, destination received a packet, meaning is source receive an acknowledgement for that packet from destination. So what source will do, the packet, it thinks it is not received by destination, so it will send that packet again. It send that packet again, and it will wait for once it is received acknowledgement for that packet from destination. So source think destination received a packet. Okay, source will understand whether destination is received a packet or not based on the acknowledgement. Guys, understand this part?
Yes, sir.
Yes, sir.
This is TCP type of communication. UDP type of communication. Source is KPC and I have a destination, that is my BPC. Source send a packet. So destination received or not, I don't know. Source send a packet. Destination received or not, source don't know. Source send a packet. Destination received or not received? We don't know. For example, this particular packet is not received by destination. Still, source don't know whether destination received or not. So it is because no acknowledgement here. Okay, guys. TCP type protocols behave like this. It is a acknowledgement based protocols. UDP type protocols will send a packet and does not know whether destination received or not. Okay. Yeah. Okay. So TCP type protocols are HTTP, SMTP, TFTP, SNMP, but literally you required the table. Which protocol is TCP type, which protocol is UDP type, which is both. Okay. So, and UDP type protocols are DHCP, TFTP, DNS. So usually DNS, both TCP, UDP type. Okay. TCP type protocols are reliable protocols and UDP type protocols are non-reliable protocols. Connection oriented, connectionless. Guys, reliable, connection oriented. Why it is? Because of source knows destination is received a packet or not. Why TCP is called TCP protocols are called reliable protocols or connection oriented protocols because of source knows destination is received a packet. Source and destination, a continuous connectivity we can understand. Okay. Next is a UDP protocol, means user datagram protocols, and non-reliable connectionless, means source don't know whether destination is able to receive a packet or not. So source will send a packet whether destination is received or not. So source don't know. Okay, it is not acknowledgement based protocol. Guys, some people mistakenly understand, even some people are teachers like that, but connection oriented, connectionless means wide and wireless kind of concept. No guys, connection oriented, connectionless is like a source knows destination is received a packet, means it is having a two-way relationship with the destination. Source and destination having a knowing each other, like so it is received or not. Connectionless, we don't know the destination is received a packet or not. That's it is connectionless, not a wider wireless communication. It's not belongs to that point. Okay, some people mistakenly telling an example wide and wireless. No, that is not an example. Because I am connected with wireless, my mobile phone, laptops, we connected wirelessly. It means only we are working with UDP protocols. It's not like that, no. Protocol is a protocol. The behavior we are telling in TCP and UDP type. Yeah, that is enough. So what happened in a transport layer? It multiplexes and demultiplexes TCP and UDP protocols. What protocols you are using in your communication? It kept in the TCP under TCP layer and UDP things under UDP part layer. Okay, UDP protocols you are using, it kept in a UDP box. Okay. Flow control or windowing. There is a two things are there, guys, about a flow control and windowing. One is, first of all, estimate how much destination device can able to receive. I'm having a 1 Gbps network speed. My net is 1 Gbps. My adapter is, I can able to send 1 gigabit of data, 1 Gbps. Okay, so destination receives, I'm sending 1 Gbps, so destination is only 100 Mbps. Its capacity is 100 Mbps. It's a fast Ethernet, it is gigabit Ethernet. So I can send this much capacity data, but it cannot able to receive it. So what you have to do, estimate the destination currently can able to receive the packets and will send according to it. Will send according to. Otherwise what happen? You send a lot of packets to the destination don't have capacity, it will drop the packet. Okay, again you have to send it. So that's why flow control windowing, and that too in windowing. In windowing, you have to tell how many packets you are sending. So destination will understand there is a 10 packets you are sending, it will count 10 packets as a one single shot. Okay, you're sending a 10 packets at a time, 20 packets at a time, like that. So you have to tell in windowing. Up to here, guys, I told something, okay, about application layer, presentation layer, session layer, and transport layer. Guys, remember, data in an application layer called a data only. Whatever the layer data, whatever it is, the layer it is, the data in the layer, we call it as a PDU. Whatever the data in the layers, we call it as a PDU, packet data unit. In first three layers, application layer, presentation layer, and session layer, the data in these layers are called data only. The PDU is data. But in a transport layer, the PDU becomes segment. Okay, data from transport layer to network layer, the data, the PDU, we call it as a segment because of data from the session layer added with a TCP header. What is this TCP header? Contains information about segmenting, numbering, protocols, TCP UDP, multiplexing, windowing information, stores in this TCP header only. This TCP header is added to your data PDU from session layer. The total PDU, the total data from transport layer, we call it as a segment. This segment is sent to the network layer. This segment sent to the network layer. Guys, understand transport layer and segment?
Yes,
Yes, sir.
Network layer. Network layer having two sublayers, routed protocols and routing protocols. Routed protocols. I received a message from home. Okay. Routed protocols means logical addressing. It means it is about your IP addresses, IPv4 and IPv6 addresses. Okay. So when you are communicating, you need a compulsory an IP address, logical address. Need a IP address. Without IP address, you can't communicate in the network. So that is the IP address. Routing protocols. Routing protocols will tell you how to reach the destination. Routing protocols will tell you, based on routing protocols, there is a route. It means how to reach the destination. Okay. And there is a network header is added to your segment and it is created a packet. What is this network header? Its network header is about your source IP address and the destination IP address. So what is a network header? So source IP and destination IP is added to your segment, that is called actually a packet. We are keep calling and using this packet word in a multiple places, but originally the packet means contains its source IP, destination IP, and your PDU from transport layer called segment. So what is now our PDU? Is packet. The packet sent to the data link layer. Just understand what is network layer?
Yes, sir.
Yes, sir.
Next one is data link layer. So from transport layer, we got a segment is go to the network layer. Network layer is added with the source IP and destination IP to the segment. It become packet. The packet is sent to the data link layer, but data link layer also having two sub layers. One is LLC, logical link control. Another one is a MAC layer. Okay, MAC layer. So LLC, logical link control, actually dealing with the WAN protocols. Okay, actually it is dealing with the WAN protocols. When you are connecting to the WAN, so you need to connect with the WAN protocols. LAN and MAN, normally we are telling based on a geographical range or geographical size. But originally it is not like that, guys. So even a very small area also you can create a WAN communication. But to communicate in the WAN network, so of course we need to communicate with the WAN protocols. PPP, SDLC, frame relay, MPLS kind of technologies to communicate, to connect in the WAN and to communicate in the WAN network. Okay. So if you are not communicating in the WAN, then it is a LAN, so no use of logical link control. Only it is when your device is communicating outside of the network, means through WAN you are communicating. It means then we have to use WAN protocol. Next is MAC layer. You know already MAC address, guys. Media access control. Every NIC has a MAC address. Every NIC has a MAC address. It is 48-bit 12 hexadecimal. It is 48-bit in binary represented in 12 hexadecimal. MAC address is also called as physical address. It is also called as physical address. So in our system now, it is for our packet which is from data network layer. So for that packet, there is two things are adding. One is data header, another is data tail. So what is data header? Source MAC address, destination MAC address, packet plus CRC. So I click redundancy check. What is CRC? CRC is an algorithm. It is cyclic redundancy check. What is the algorithm? What is use of this algorithm? To check errors. When you receive a data at data link layer, it verifies any data corruptions. So data came good way or corrupted. You receive a packet, so its packet may be while traveling, data may be corrupted, right? So error checking happens at data link layer. Error correction will happen at transport layer. Okay, CRC, cyclic redundancy check, is an algorithm used to check the data. Okay, you can say error detection also. Okay, source MAC address, destination to your packet and CRC become frame. The PD you call frame from data link layer. The frame sent to the physical layer. In the physical layer, the frame convert into bit stream again convert into electrical signal or radio signal or a light wave based on the medium. The frame is sent to the physical layer. That physical layer is convert your frame into bit stream. Okay, and that phase stream based on your connectivity. You connect to your wide connectivity means it's electrical signal. If it is a fiber optical type of connectivity, it become light waves. And if it is a Wi-Fi kind of connectivity, then it is become a radio waves. So these are the totally 7 OSI layers. Guys, understand anything?
Yes, sir.
These OSI layers are very useful for troubleshooting and understanding the network related kind of stuff. Okay, so actually I want to complete both OSI layers and IP addresses, but it won't happen, guys, because OSI layer having 7 layers only, but it is compulsory to understand each layer function. As I said earlier, guys, you have a source device, destination. I am pinging from my source. For example, this is my command prompt. Application, command prompt is an application. Command is ping. Protocol is ICMP protocol. I am pinging to one of my device. For example, I am pinging to this one. See? I'm pinging to a device. I got a reply from the remote machine. Okay. First of all, I'm sending a request, and now I received a reply from destination. Right. So this is an application, and this is the command, and it uses a protocol called ICMP. Okay. So that is a ping. So what happened when you dive ping? When you open something from your browser, right? Like that, right? So first is application layer related things. Presentation layer. So data is converted into ASCII, ASCII to binary, binary to ASCII to binary, and data is compressed and data is encrypted if in case of using encryption. The session ID will attach the requirements for your data and create a session ID. Transport layer chop the data into small pieces. Okay, means called segment the data and put numbering on it. Segmenting, sequencing, numbering, all these things. Okay, and decide what protocol type it is, TCP UDP, like that. Windowing for transport layer. Network layer attach source IP, destination IP to your segment, and it become a packet. The packet is go to the data link layer, added with the source MAC address, destination MAC address, plus CRC, cyclic redundancy check, algorithm for error checking, and it is become a frame. The frame is converted into bit stream, and it is converted into different form as based on the what kind of media you are connecting. For example, I am using normal wide connectivity, so data become electrical signal. And this electrical signal received at destination PC means PCB. It convert this electrical signal into bit stream to frame. And that frame is go to the data link layer at destination. So data link layer verifies source MAC address, destination MAC address, and CRC. It verifies the data with CRC, data is good or corrupted. Okay, data is good. So it keep a side of source MAC address and verify with the destination MAC address against the PCB. Okay, once it is extracted, this part, we got a packet. The packet sent to the network layer. Network layer verifies source IP and destination IP. The destination IP matches with the IP address of PCB, it accepts the packet. Otherwise, it will drop the packet. Okay, so it verify your destination IP address against PCB IP address. So it is okay, then it will accept the packet. And these two are separated. We got a segment. The segment is sent to the transport layer. Transport layer check numbering, sequence order, and then also verify the TCP UDP protocols. Okay, kind of stuff. Once it is done, it assemble all packets at transport layer. Once it is received, one by one packet we are receiving, it assemble all the packets at transport layer. That's what it is. Transport layer is end-to-end connectivity. At transport layer only data is assembled. And this total data is given at session layer. Session layer verifies this session ID, authenticate the connectivity. Okay, then it is go to the presentation layer. Presentation layer convert the data, means the binary format to ASCII, ASCII to application understandable language. Okay, and decrypt the data, decompress the data. So you got your data now, then data is sent to the application layer. Application layer verifies what is your request based on your protocol. Okay, according to that application, and then your request, you will receive it will try to give reply. Guys, while it is replying, again, application layer, destination side, application, presentation, session, transport, network, data link, and physical layer. At source means PCS side, again physical, data link, network, transport, session, presentation, and application. Okay, 7 to 1, 1 to 7, 7 to 1, 1 to 7. Okay, that is will happen. That's why always, if possible, if you are new to the OSI layer, try to go with always 7 to 1, means application, presentation, session, transport, network, data link, and physical layer. Let's understand how the data will flow from one device to another device based on OSI.
Yes, sir.
Yes, sir.
Yeah, small protocol, guys. When you receive a data, this side, PCB, at PCB receives a source MAC address, right? ACE MAC address received at PCB. So what PCB do? It kept this MAC address aside. Next, once packet is extracted, the packet contains a ABC IP address. ABC IP address, that is also PCB will kept aside, and it maps like this. It maps IP address, means ACE IP address to ACE MAC address in the system. ACE IP address to ACE MAC address in the system. Why it is? If we want to communicate A, that time we will know B's ACE MAC address. Okay, we can see here. You know, one thing will happen. Even last class I showed switch and hub kind of stuff. Okay, so look at here, two devices I'm pinging, for example. So I send a packet to A to B. I know B's IP address. I know my IP address, that is A's IP, but now I know B's IP address because that's why I'm sending, right? Without knowing, we cannot send. So I send it. But what I don't know, I know A's MAC address. A know A's MAC address, but A don't know B's MAC address. A don't know B's MAC address. So what A do? A use 12F's MAC broadcaster. It is a MAC broadcaster. Okay, so I don't know the destination MAC address. What I will send with this broadcast MAC address. But of course, the packet sent to everyone because you're not sure about it, who is the physically or who is the person. So everybody will receive a packet. First verify the destination MAC address, then destination IP address. Okay. So B has same IP, so it will accept the packet. Okay, even it is a different MAC address. Now B has to send a packet to A. B to A. Same problem. B knows its IP address, B knows A's IP address. And B also has its own MAC address, but B don't know about A's MAC address in general. But this will be changed. How? Because A don't know B's MAC address, but B received a packet from A. The packet contains source IP address and source MAC address. Using a protocol called ARP, Address Resolution Protocol, it maps A's IP address to A's MAC address. But this time, I am now my A's MAC address. Because I know A IP address, so then I know A's MAC address because I learned I created a map. See, look at ARP space -A. See this? I know the destination device MAC address. Destination device MAC address. Okay. It is like that. What is ARP? Address Resolution Protocol. To check what is the IP address and map it to different physical. Means this is a device. This device analysis MAC address is this one. This is my remote device. This PC's MAC address is this one. Okay, so I will learn dynamically, and you can also add statically. To add statically, this is the command ARP space -S IP address and remote device. That IP addresses device MAC address. You can add statically also. To see it -A, to add -S, to delete -D. Okay. ARP, Address Resolution Protocol. Whenever a device received a packet from a device, okay, it will try to gather its MAC address and IP address, tabulate into IP address, map it to MAC address. That is ARP, Address Resolution Protocol. There is a reverse is also there, reverse address resolution protocol or ARP, which is reverse. What is the use of ARP, guys? Usually used in security related places. Yeah, I will tell one more, then we'll leave for today. Okay. Understand, guys, what is ARP, address resolution protocol, and this part.
Yes, sir.
Yes, sir.
Actually, there is some more comments are there. Just I will give the comments only. So tomorrow we'll discuss IP address directly. Guys, there is always a comparison between OSI model and TCP or DoD model. Already I told we are all using TCP IP model only, which is earlier than OSI model. Okay, some people think we are using OSI, not TCP, because TCP is a worldwide. OS is the reference model for understanding network functionality, and it is used for a troubleshooting also. Guys, as OSI model, application layer, presentation layer, session layer is application layer. Okay, in application layer at TCP means TCP IP having only 4 layers: application, transport, internet, network access layer. I given these names based on the old textbook kind of stuff, guys. Some internet people, some textbooks, they are keep changing the names. I am giving standard DoD model 4 names. Okay. So TCP IP application layer is equivalent to the OSI model application presentation session layer. TCP IP transport layer is equivalent to OSI model transport layer. TCP IP internet layer is equivalent to OSI model network layer. TCP IP network access model is equivalent to network data link and physical layers. Okay, so we have 4 layers. TCP IP application layer is in OSI model application presentation session. These 3 things done by one single layer only. Transport layer is transport layer, internet layer is network layer, network access layer is data link, and physical layer of OSI model. Guys, so I said as per OSI, physical layer example is hub, data link layer is switch, router is belongs to layer 3 network layer, right? What about NIC? The LAN cards we are using, NICs we are using. So 5 minutes, 10 minutes, 20 minutes, 30 minutes. Let's just 5 minutes. Okay. As per TCP IP, the NIC comes under network access layer. Why? Because of NIC having a MAC address. MAC address comes under data link layer. NIC used to connect devices physically. It comes under physical layer. Okay. So it is NIC comes under, we can say only data link layer or combination of data link and physical layer as a network access layer in a TCP IP. Okay. So compulsory read once, guys, at least read once, so you will get to know what are the use of all this kind of stuff. This is entirely troubleshooting related. We'll try to finish this troubleshooting part tomorrow. Okay, IP config, you know how to check IP address, IP config command, IP config all, get MAC, ARPA, ping, trace RT. These commands already I told, at least from here I told. IP config is there, IP config space / all is also there. Okay. So in IP config, there is a 4 type of commands also there additionally: release, renew, display DNS, and flush DNS. IP config release is flushes or removes your dynamic IP addresses. Renew to get an IP address from DHCP server. Net stat and root P to what is your routing table to get it. So you will find it root print. P means print. Which one you want to print? You can see. Yeah, you have to tell which protocol, IPv4, IPv6 protocol. Okay, so it is not understanding -p. You have to give root print. Okay, it's printing the routing table, IPv4 routing table. Okay, so ours is Wi-Fi adapter. This is interface index list is 35. Okay, so this is a root pin kind of stuff. Netstart will tell you how your packets are sending. Like if I open a browser and open something like this, so that related information, local address, foreign address kind of stuff, it will be shown. Yeah, pinging is also a good thing. Yeah, so I'm getting pinging. I ping to google.com. It is that related IP addresses, we will get it. TCP type protocol, so it take a lot of time to get it. So we have to do continuous pinging. Okay, guys. So that is for today. Tomorrow we will discuss about IP addresses and troubleshooting also. We'll try to finish tomorrow.
Okay, sir.
Sir, please mark my attendance.
What is your name?
Sir, Ravi, I joined a little bit late.
Okay.
Yes, sir. Thank you so much, sir.
Thank you, guys. Read. Okay. So after the document I am sending,
Okay,
already there. I already sent the document. Please go through once. Okay. So I will try to conduct some test. So maybe tomorrow I will do it that one. Or today I will send it.